In this lesson, we will be solving polynomial equations by using factoring or other methods if needed. So in our first example, we want to solve our equation. So what we will do is factor, and when we factor, we find out what they have in common, and it looks like we have a 2 and a y squared in common. And so when we divide, we have y squared minus 9, and all of that is equal to 0. So we want to make sure to factor completely. So we have a 2y squared, and then we have a y plus 3 and a y minus 3. Set those equal to 0. So if we set 2y squared equal to 0, and we divide by 2, and then we take the square root, we would find out that y is equal to 0. And then we set each of these equal to 0. We have y is equal to negative 3 and y is equal to positive 3. And those would be all of our solutions for this particular polynomial. When we take a look at the next example, we have x cubed minus 27 is equal to 0. So we have our difference of perfect cubes. So we want to factor that using our pattern. Remember, we're going to take the cube root of the first term and the cube root of the second term, which is 3. And then to complete our pattern, when we're factoring, we square the first term. We multiply these two terms of our binomial together, 3 times x, so that'll be plus 3x. And then we square the last term, which would be 9, and we want to set that equal to 0. But we need to continue factoring on this trinomial because it is a quadratic. The problem is there are not two numbers that I can multiply together to get 9, and when I add them together I get 3. So this is not going to be factorable, but we still have to find the solutions. So for this one, we're going to need to do the quadratic formula. For the first binomial, we can set it equal to 0, and our answer would be 3. This one, we will set up the quadratic formula. So x equals negative b, which is negative 3, plus or minus the square root of b squared, which is going to be 3 squared, minus 4 times a, which is 1, times c, which is 9, all over 2 times a, which is 1. So we have x equals negative 3 plus or minus the square root. 3 squared is 9, and then 4 times 1 times 9 is 36. So we have 9 minus 36, which gives us negative 27, and that's all going to be over 2. So we need to simplify our root, and we have negative 3 plus or minus. When we make a factor tree to simplify the square root of 27, we have 9 times 3 or 3 times 3. So we're going to bring the 3 out as well as the negative 1. So we have 3i, and then what's left under the radical would be the square root of 3 all over 2. So these are going to be my 3 solutions. We have x equals 3, and then x equals negative 3 plus or minus 3i squared, so 3 over 2. Taking a look at solving our next example, first we want to make sure that our polynomial is set equal to 0. So we have x cubed plus 2x squared minus 9x minus 18 is equal to 0. Our polynomial is written in standard form, and it has 4 terms, so we're going to factor by grouping. The first 2 terms have an x squared in common, which leaves us with x plus 2, and our second 2 terms have a negative 9 in common, which leaves us with x plus 2. So when we're factoring by grouping, we're going to take the first monomial and the other monomial and put them together to be our binomial, and then we have our x plus 2, and that'll be equal to 0. But we want to make sure to factor completely, and I hope you recognize that x squared minus 9 is the difference of squares. So we have x plus 3 and x minus 3. And then we have our other factor of x plus 2. And we want to set all 3 of these equal to 0 and solve. So our solutions are x is equal to negative 3 x is equal to positive 3 and x is equal to negative 2. In our next example, we're going to subtract 81 from both sides. To set our polynomial equal to 0, we have 16x to the fourth minus 81 is equal to 0. We should recognize that 16 and 81 are perfect squares as well as x to the fourth because we can multiply x squared times x squared to get x to the fourth. So we'll take the square root of each, which gives us 4x squared minus 9 and 4x squared plus 9. So we can still factor the 4x squared minus 9 into 2x plus 3 and 2x minus 3. So we can set those equal to 0, and then x is going to equal to negative 3 over 2, and x is going to equal to positive 3 over 2. Now with our 4x plus 9, we can solve this in a variety of ways. We can't factor it any longer. So we could use the quadratic formula if we like, or what we could do is simply solve it by taking the square root. So we have 4x squared plus 9 is equal to 0. We can subtract 9 from both sides. We have 4x squared is equal to negative 9, and we can divide both sides by 4. So we have x squared is equal to, leaving it as a fraction, we have negative 9 over 4. So when I take the square root of both sides, and the reason I left it as a fraction is I can tell that both of those are perfect squares and I can take the square root, x is equal to plus or minus, don't forget, the square root of negative 9. Well, the square root of 9 is 3, and the square root of negative 1 will be I, so we have 3I over the square root of 4, which is 2. So these are my four answers: negative 3 over 2, positive 3 over 2, and then plus or minus 3I over 2. So remember your rules for factoring. Make sure you take out your common monomial factor. Check if you have any special cases, which would be the difference of squares or perfect square trinomial. Also remembering our patterns for difference of cubes and sum of cubes. And then remember our factoring by grouping. So when we're solving, we're going to set the polynomial equal to 0 and factor, and then we're going to solve. Sometimes we might need to use the quadratic formula, and also sometimes if the b value isn't there, we can also solve by simply taking the square root.